Hi, I'm Robert Curtis. I'm the head instructor of the Distance Calculus program. In this video, I'm going to talk about the Linear Algebra course. Now, Linear Algebra is a sophomore or junior level course. Most schools it's sophomore, but some schools it is actually a junior level course. And there are two different Linear Algebra courses, and this is technically the lower course. The lower Linear Algebra course. There is usually a higher Linear Algebra course, which is often called Abstract Linear Algebra, and this is not that course. So Abstract Linear Algebra is generally taken only by math majors in their junior or senior year. Rarely is it taken by anyone else, but Linear Algebra is usually a sophomore level course, sometimes a junior level course at some schools, but mostly a sophomore level course. It's usually the last course in the calculus freshman and sophomore year curriculum. It's usually the last course you take. Now, if you are that student, if you're a freshman, some freshmen take the course too, but sophomore level Linear Algebra, then this is the right place for you. And I want to talk about how this course is different than the classical linear algebra and then the modern linear algebra. And I'll also talk about the prerequisite. The prerequisite for this course, if I can remember how to spell today, is Calculus 2. And why is that? There is absolutely no reason why Calculus 2 is a prerequisite for linear algebra. You will not use any Calculus 2, any derivatives, nor any integrals, except at the end a little bit, in linear algebra. So why do we have linear algebra requiring Calculus 2 as a prerequisite? It is purely for a thing called mathematical maturity. The concepts of linear algebra are rather advanced, and they are very difficult to wrap your head around. And if we tried to teach linear algebra to freshmen before they took Calculus 2, they would not do very well. They would really struggle with it. It's interesting, there have been some educators who have tried to move linear algebra back into the curriculum, and some topics of linear algebra actually now appear in the pre-calculus course in high school. It's a nice idea. It's good to do a little dabble of linear algebra in high school, but the really difficult linear algebra course, if you tried to do it without Calculus 2 as a prerequisite, it would not be successful. So you do need the academic prerequisite of Calculus 2. However, if you don't remember any Calculus 2, hopefully you remember a little bit, but if it's been a number of years since you took Calculus 2, but you still have Calculus 2 on your academic transcript, then you are cleared to take linear algebra, and you do not need to remember any Calculus 2 to start linear algebra. Linear algebra is its own course. It is completely different than calculus. Why it's called calculus, I'm not quite sure. Why it's part of that array of courses, but it's just the course that you take as a sophomore, and so it's kind of grouped into all of this stuff. Now, when I was a student, way back when, and I won't say how many years ago, 35 years ago, I took linear algebra as the classical approach to linear algebra. The classical approach is based on hand calculations and when I took the course, there was absolutely no computer usage whatsoever. Even though I did as a precocious little student, I took it as a freshman, and I was a precocious little student, and I went off to the computer lab and I found this wonderful program called Maxima, which doesn't exist anymore. And I did all my homework in Maxima. And it was great fun to, put all these matrices into maxima and get the answers out, and I felt very powerful indeed as a freshman playing around with this stuff. But the intention of the course was to learn hand calculations and then also abstract algebra. Now, I say that because this is actually a course for math majors when they become a junior or a senior in a pure math degree, is that they go and study a course which is very difficult called abstract algebra. And in a classical approach to linear algebra, the ideas of abstract algebra start to come into play. The idea of first looking at what's called a linear space as an abstract algebra construction and proving that certain things are linear spaces or vector spaces is part of a classical approach to linear algebra. Now, if you are a pure math major, you really need to check with your department to see if they will approve you taking a modern approach to linear algebra. Our course is definitely a modern approach to linear algebra, and it is not a classical approach at all. For example, in a classical approach to linear algebra, you learn how to do row reduction of a matrix by hand. So you're given a matrix and you're taught how to row reduce it down into reduced row echelon form or row echelon form in solving a system of linear equations by hand. And that is the whole idea of a classical approach, is that you understand the calculations by hand. All right? If you need a classical linear algebra course, this is not the course for you. All right? And we do get a number of pure math majors, students who are planning to go study mathematics and a bachelor's degree in mathematics, and they are seeking out our course, and I have to tell them, go talk to the chairman of your department and see if they're going to be okay with a modern approach to linear algebra. And most of the time they come back and they say, no. Math majors don't get to take a modern approach to linear algebra. They need to be very good at these hand calculations and basically to get ready for this abstract algebra course, which is what they're going to take next after linear algebra. So if you are a pure math major, check in with your department to see if the modern approach to the course is going to satisfy their needs for the course. If you are a math major but you're not going on the pure track, if you're on the applied track or the computational track, which is very common these days, you'll be fine now, because this is going to be the course for you. You will not be learning how to do row reduction by hand. Definitely, absolutely not. You will be using instead a modern tool. We use the program Mathematica, and we use the courseware is called Matrices, Geometry, and Mathematica by Davis, Porta, and Ewell. Davis, Porta, and Ewell. Davis from the Ohio State University and Porta and Ewell from the University of Illinois at Champaign-Urbana. Matrices, Geometry, and Mathematica. Bill Davis, I believe, wrote in this book, or he said it to me. I can't remember right now, but I remember him saying, characterizing this book is, this is not your parents' linear algebra course. And that is absolutely, definitely the case. In fact, this curriculum is so unique that the cornerstone of the analysis of matrices that they used using singular values, using what's called the singular value theorem, is not found in almost any other textbook at all. It's amazing. But the fact that you're using Mathematica as a very powerful tool, and it can do a singular value analysis of a matrix like that, allows you to open up all kinds of things about linear algebra that you cannot do unless you have a tool like Mathematica. The way I describe it, one way to think about it is if you go into a chemistry lab or a biology lab, you are going to have test tubes in chemistry lab and you're going to mix chemicals, and in a biology lab you're going to have a microscope and you're going to look at things. This is like a chemistry lab or a biology lab, but for mathematics. Imagine if you took a chemistry course and you didn't even step foot into the lab. You just did everything abstractly. You wrote all of the chemistry equations down abstractly. And that's okay. That is chemistry still, but somehow something's missing if you don't have that lab experience. And mathematics actually is a wonderful platform for having a lab experience, and the lab experience comes from Mathematica. So, in this textbook, Matrices, Geometry, and Mathematica, we get to go through a very, very modern approach to linear algebra. You will not learn almost any of the techniques of manual computations. In a classical approach, you learn something called finding eigenvalues. One teacher, I remember my teacher in linear algebra said, the whole point of this course is for you to be able to calculate eigenvalues by hand of a matrix. Any given matrix, you calculate that matrix's eigenvalues, and that tells you something about it. Well, when I went through linear algebra, I could calculate eigenvalues, and I had absolutely no idea why. I calculated, here's my eigenvalues, I got them. And I had no idea what it was for. Now, they said, oh, you'll learn about it in the next course. Well, I really didn't learn about eigenvalues. I didn't really understand eigenvalues until I got to graduate school in mathematics. That's a long wait. That was like 4 or 5 years of a wait before I finally understood what eigenvalues were. In this modern approach using matrices, geometry, and Mathematica, you are going to know what eigenvalues and singular values of a matrix are. You're not going to be able to calculate them by hand. You won't be able to. There's a couple of examples with eigenvalues by hand. There are some hand calculations we do in the course because you need to have some literacy. But in general, you are going to have to go get your tool, Mathematica, and attack that matrix and get out the information from Mathematica. But what you will know is how to use that information. You will walk out of this course with a grand knowledge of how matrices and geometry, the G in here is very important. This is an extremely geometric textbook. You will understand how all of that information coming out of Mathematica, what it tells you about the matrix, what it tells you about the geometry of the matrix, what it tells you about how the matrix interacts with things called linear spaces or vector spaces. You will have a grand knowledge indeed, and I claim you will have a very powerful understanding of linear algebra when you complete this course. I've had many students write me years after they completed the course and tell me, wow, I use that stuff from that linear algebra course every single day. It is fantastic. I love that stuff. And this course really shines in the Calculus and Mathematica courseware series. It is a fantastic course. It is a very long course. It goes 11 modules, and it is very long, and it does a modern approach, but it actually surpasses whatever a traditional linear algebra classical course goes through. It does probably twice as many topics. And some of them we just can't do because we just don't have time. It's only a 4-unit class. So some we have to skip. But we find many students actually go through the extra modules that are not assigned just because they're having so much fun going through this. And I know you're saying, I'm not going to have so much fun in this class, and I claim that you will. This is really a fantastic, fantastic course. Once again, it does not rely upon really any Calculus 2 knowledge whatsoever. So if you're rusty in that area, don't worry about it. You do not need to go back and start reviewing Calculus 2 topics or even Calculus 1 topics to really take off in linear algebra. Having said that, it is a very difficult class conceptually, and it's why there is a Calculus 2 requirement. So I have watched very, very good students, very strong mathematical students who breezed through Calculus 1, hit linear algebra, and go, whoa! And really, not struggle in the sense that they didn't eventually succeed, but actually have to really think about it and put in some extra work. And they have all said that course was a lot more difficult than Calculus 2, which is a very long, difficult course. But they were able certainly to get through it. That is without question, but it required a lot of effort from them. So this is not an easy course by any means. You can take differential equations and or multivariable calculus at the same time. They're kind of like the three courses you can take. You can go take linear algebra, you can go take differential equations, and you can go take multivariable calculus all at the same time out of Calculus 2. I always recommend that you take multivariable calculus first, and then you could go take linear algebra and differential equations together at the same time. That's a nice mix. They don't have anything really to do with one another except at the end of the course. At the end of the both courses, they kind of come together in this wonderful, wonderful way. Both curricula do, it's a realization of a dream that has been around for many, many years in math education of combining these courses into one. And there are some textbooks now that are called linear algebra with differential equations or differential equations with linear algebra. There are some schools that actually combine the two courses into a single course. It's not a universal thing that can be done across the board. So we, of course, at Distance Calculus, we need our courses to transfer to other institutions as generally as possible. So we can't do a combined course of linear algebra and differential equations, but you can take them together. And the curricula will come together at the end of the courses in a very nice way. You will get to be an expert on Mathematica. If you feel that your computer skills are a little weak, they won't be weak after this. And it is a very nice change if you took Calculus 1 and 2, or even multivariable calculus, which we use the live math software for. In differential equations and linear algebra, we change gears on our little sports car and go into high gear with Mathematica. It is, the next tool to use after live math, and it is a very powerful, powerful tool. Having said that, it is also an aggravating tool. You will have computer problems where, this code should work, and I'm not getting the graph out, or I'm getting some programmer's error. What does this mean? My blah, 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 blah is not blah, 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 blah. You'll have some of those days. And it is just, unfortunately, part of the situation of using a very advanced tool. And I will help you. I'm not an expert at Mathematica by any means, but I can fix things and generally be able to fix things to make them work, and say, oh, you had a comma out of place, or you had this square bracket out of place. Unfortunately, you are going to feel a little bit more like a programmer at this level than using a math tool that kind of hides the programming like we used in the Calculus 1 course. But it's nice to be able to change gears and go up to the next level of computer algebra software, and that is definitely Mathematica. All right, well, hopefully I've given you some of a preview of the course. There are some other videos on this page that look at some of the curriculum topics, and I invite you to go look at those and see if they look interesting to you. Your decision on whether or not to enroll in the course may not be based on whether or not this seems like a really cool course. It may just be based that you have to have linear algebra and it's part of your degree requirement and you need to go do it. The modern approach, if you are in physics or engineering or economics, you will love the modern approach to linear algebra because it has it's so powerful. There are a number of applications examples in the textbook, not a lot, but some, but it mostly stays along the lines of mathematics. But you will see, if you have taken physics courses and engineering courses, economics courses, you will see some themes from those courses, and you will say, this is what we learned in physics, or this is what we learned in engineering. This is what we're going to use to solve some problems in those other disciplines, and take that information back to your other disciplines, and you're really going to have a very powerful tool. Once again, I reiterate, if you are a pure math major and studying for a pure math degree, check with your department before enrolling in this course to make sure that they are going to accept a modern linear algebra course. If you're not a pure math major, if you're not a math major at all, physics, engineering, computer science, etc., they're going to love the fact that you're doing a modern course, because doing all of the hand calculations from classical linear algebra is not really useful for those other disciplines. The stuff you're going to learn in this course is definitely going to be useful for those other disciplines. If you have further questions, please write me an email or a chat, and I'll try to help you make a decision on your course enrollment. We'll talk to you later.